All right. Willkommen zurück. Cool. So one quick little announcement for the next session. After the next session, sometime after it, there will be some kind of hot ironing, wood burning exercise happening in the garden. So go and check that out in the garden. Bring the wooden bowl and get it burned somehow. Cool. So moving swiftly on, you wake up in a strange land feeling like a nobody. Your wrists hurt, your legs hurt, you can't move. You're on a pirate ship, bound for Meereen. You've been captured. You don't have time to wonder what Angus MacGyver is doing in an episode of Game of Thrones, but then you remember that episode where he traveled back in time and met Merlin, and it makes perfect sense. MacGyver has been imprisoned with you, but of course he's fashioned an elaborate plan to use barnacles strengthened by paperclips and porridge as swords to escape. You suggest using the Acme Arduino jetpack that's lying in the corner. He agrees, and a few minutes later, you're floating above the ocean, the ship leaving a trail behind. In the distance, you see a church and a man called David.
Thank you. Oops. Thank you. I'm a Linux user. I don't know the command key. Here we go. So before we start, I have to give you a parental advisory. I never run on a Macintosh, so when I do, my fingers bleed. So for this presentation, I had to pack everything into a lot of highly pixelated animated GIFs. So at some point, your pixel-perfect eyes, because of your retina displays, might start bleeding as well. So please try not to make things too dirty. So just briefly about myself. I'm a researcher at the Internet of Things and People group at Malmö University. And I'm one of the co-founders of the Arduino project. And right now, I'm the education manager for the Arduino project. So I'm going to be talking a lot about things people do with Arduino boards, basically. And I like to call this presentation the 1, 10, 100, 1,000, or since we are among software people, it's the 1, 2, 4, 8 presentation. Sorry for the geeky joke. But this is really about scaling up. Because when we designed the Arduino platform, we were really thinking about mostly groups of 10 people at once. And now we're talking about that when we design something, our user groups are groups of 1,000 people at once. And I hope I will manage to get this message through about how we manage to scale things up on the way. But since we are at a monastery kind of presentation day, I have to tell you about how things started for me in religion. So this is in 2003, and I was part of an art group called Am Ende sind wir alle Deutsche, which means for the non-Germans here, in the end, we're all Germans. And we teamed up with another group called Answorn, which doesn't really mean anything. But these Answorn people had the idea that we were going to become more and more dependent on electricity. So we came to believe that there should be a religious group dedicated to praise the goods of the virgin powers of energy. So we will travel the world with our pilgrim outfits, blessing power plugs and recharging our outfits in the power plugs. And the thing is that these outfits, they were designed so that they were like tied up together with electromagnets, and you were carrying a battery on top of your stomach, and if the battery was getting discharged, then the electromagnets will release each other, and the whole outfit will fall apart. And we were running commando under this thing, you know. So the whole idea is that you will end up naked in the middle of Copenhagen, and that is not so good. It's a very conservative country. So when I've made that first design, I started to think, how can we make this thing work? How can we design? I'm a microelectronics engineer. I do a lot of hardware for a living, and I do software, and I teach people about it. And I started to think, like, how can I explain my students at the University of Malmö in Sweden, they were art and design students, how they could do something like this. This was a performance, and it was fantastic. We really got the message through. We had a lot of fun. We managed not to get naked in Copenhagen. We had to hijack falafel places and plug ourselves instead of the fridge and things like this. Some yogurts got destroyed in the process. But the question was, how can we design things easily with electronics? How can we get people to build these things? So I thought I should help my students making their own electronic boards so they could build their own projects. So I would take my students, that was in the first year of introduction design, and they knew barely how to program. I had been with them for 6 months, teaching them some Java, and I told them, today, I'm going to initiate you in the novel art of soldering. And 12 hours later, they had their own personal circuit board. And they could start building their own projects. And the kind of projects they were doing were, for example, the alcophone. We're in Germany, beer is pretty cheap. You can buy beer at 12 in the night at places and stuff, and you will not get broke. In Sweden, it's not like that. You have to go to the official store and buy it during daytime, and you have to plan your drinking, like, oh yeah, I'm going to drink 4 beers tonight. And so people tend to get very wasted, literally. Nobody will ever invite you to anything if they are not really looking for something from you, So people tend to drink a lot. And there is these people that you only want to meet when you're drunk enough. So my students had the idea of making this phone that will only let you call your drinking buddies when you've been drinking enough. So you had to blow into the breathalyzer, and this was, I don't know how many of you were ever developing for the Sony Ericsson T610, but the only thing you could really program in was a software called Mofan that was made by some Russian guys. So we, in a forum, somehow wrote in English and got it in Russian and then asked questions. And then we developed this application that was looking into the internet for a number. That was the amount of alcohol in your blood. The circuit was like sending your data from a computer to the internet. And I'm losing my voice. I know. So what happened was that, we got it to work. And so when you were blowing, it was telling you, OK, you didn't drink enough. You will take one more sip of the beer, blow again, tell you, oh, welcome. You can call Peter, Hans, Hannah, whatever. And then the more drunk you were getting, the shorter the list was becoming, because you don't want to call your ex-wife when you're too drunk. If you haven't been there, I don't recommend it. And then in the end, you could only call your trust taxi service. But since we are at the church, let me tell you about other of the projects that was made by the students, and it was an automatic confession booth. I think this project would have been fantastic for this gathering, brothers. And this was a machine that was hacking a CD player. Remember, this was 2004. There was not really a lot of MP3 players around. And the CD player had hundreds of sound loops recorded that said the same thing, like kneel down, kneel down. Would you mind kneeling down? Can you kneel down? Kneel down. And this board would randomize one of those sound loops to tell you to come in, to tell you to kneel down, to tell you to lock the door, and to ask you to confess. Then you would start confessing, and after a while would tell you thank you, and you were welcome to leave and pray your shit, and that was it. So we sent this to a Gothenburg Science Fair, where the Princess Victoria was going to come. This is completely disconnected from the actual fact of this invention. Okay, Princess Victoria is a person, but then when Princess Victoria goes places, the press comes as well. So the press was filming this thing because it was like a gigantic box in the middle of the exhibition hall, and a man comes out and they ask him, "Are you a Christian?" "Yeah, I'm a Catholic." "So how was it?" And he said, "It was very much like real life." So I realized that there was really a power in, building interactive experiences for people. And that was a really, really viable way of educating design and art students in the power of digital technology. Because when you build something, you establish a completely different relationship to it as when you just, draw something. And I was getting industrial design students to make interactive devices. So, but I realized that soldering the boards was not really good enough, and at some point in 2005, I met with Massimo Banzi, my partner in crime at this point, and I was sharing with him, oh, when I work with my students, I have these and these problems, and he was sharing with me, when I work with my students, I have these and these problems, and we realized that we had same visions, and we had same plans, so we started working together, and we designed the first Arduino board. This was the Arduino serial board, and we produced only 300 of these boards. It was a fantastic story. It was made in a night. It's true, you can make a circuit in a night if you have the tools. And we assigned it to manufacture. We went to this Italian factory where the guy could hardly speak English, and he was showing us boards and stuff, and I was like, oh, do you have colors? And he's like, yeah, I have colors, and he showed us the blue color. I was like, wow, this blue is beautiful. Can we have it blue? And he said, yeah, it's going to be a bit more expensive. Like, how much? Like 0.01 euro per board. I was like, wow. But I don't know if you know the history behind blue circuits. Actually, it's almost a political thing, because circuits are traditionally green. The reason for them to be green, I still don't know. If anybody knows in the audience, please approach me after the talk and tell me. I've been looking for somebody to tell me why, but I don't know. The thing is, when you are making visual inspections of circuit boards, your productivity starts to fall after 4 hours because of how shiny the green color is. But with blue color, you can run with much less mistakes for a longer time. So making blue boards is a way of enslaving the users or the students in continue working harder for a longer time. So I started like, make it blue. But you might realize that there is this one nice thing in this board that you might not see in other boards, and it's that all the components with the same values are actually grouped together. Like all the 10 kilo ohm resistors are grouped together. That's not electrically correct. You know, that resistor should be somewhere else in the board. It was just that people were going to be soldering these boards by hand as the first thing they did in electronics in their lives. So it had to be made easy for them to mount. So we made it like this. And it worked pretty well. So we made 10 boards, 15 boards. People started to call for workshops around. We made the first international workshop in Madrid in Spain, then the second one in London. The workshop started with 30 people and ended up with 60 people. It was completely crazy. People were calling friends, oh, I'm making a light blink. We were like, whoa, light's blinking. It was 2005. People were very naive, you know. There's LEDs everywhere nowadays, but back then, we were young and beautiful. And then I realized I cannot keep on soldering this thing by hand the rest of my life. Because on the front, this looked nice, but on the back, it looked like shit. You know, it's like, if you had never soldered in your life, you were doing your best, but things weren't really optimal. So as a teacher, I had to take all the 50 words from the workshop and go one by one, revising all the soldering joints to make sure that things were going to work. And that's not sustainable, because when you are educating people in something complex, and you want them to enter like high up in the system, you need to give them things that work so that they can succeed quickly. Because if they don't succeed quickly, they're going to give up really, really fast. Especially because this thing was very cheap. It was like 20 euros. So if you make a mistake and you fail, yeah, 20 euros, it was like 3 beers, who cares, right? So I wanted people to like get the thing to blink the first day and, you know, hack a CD player the second day and make a robot the third day. I wanted this to work. And the same my partner. I mean, when I say, I'm talking in first person, but you should understand, this means the whole of the Arduino community, actually. So we ended up thinking, we need to make projects with it. And this is the first Arduino project ever made. So these students, they were working with a board that you saw before, and they burned it. And I had the prototype of the Arduino board in my hand. I said, why not? Let's make this happen. And I don't know how to press play on the video. Like this? Yes. This is called the Involuntary Dance Machine. It was made in 2005.
Okay. So, we have loud music outside.
I'm going to lower the volume a little bit. Mostly because it's very noisy. This is an art gallery in Malmo, and my students are very excited because they're going to present a machine that takes control of the human body. And the whole idea is that they will choose a sound file, and depending on the different levels of sound on the different bands of the spectrum, the machine was going to electroshock an elbow or a knee. The idea behind this project was to get a dancer to dance to his favorite piece and then lose control at some point. But when you get electroshock in both knees at the same time and you fall, it's very painful. So you had to hang people with a harness from the roof, and then you didn't need a dancer anymore. You could use anybody. I'm really proud to say that this guy not only survived, he's the CEO of Us2 Sweden right now. So if you want ever interview to Us2 Sweden, just tell him I saw you in your underwear. Okay, let's move on. I really don't know how to jump to the next slide. Now, Macintosh. I should be making ads for Apple. They should pay me for this. Okay, anyway, so this is the current design, the Genuino Uno, and this is the board that you will find at lots of places. You know, there is millions of these boards, either our own designs or designs made by other people. At some point, we stopped counting when we were reaching the 750,000 million boards, you know, because we don't know anymore how many boards we make versus how many boards other people make. We only know that our software is downloaded 60,000 times per month or something. You know, it's a crazy, crazy amount of times. That we have 48 million unique visitors to our website on a yearly basis. So how many boards are there out there? We have no clue. We really don't know. You always estimate that there is 3 to 4 times more boards than we have made. So one of the key aspects behind Arduino is that we are not just a hardware platform. This is a huge mistake that people make. We realized very early on that when you work with people that don't have deep knowledge on a subject, you need to really guide them into the aspects that make this subject interesting. So we created a website where people could come and explore different aspects of knowledge, and once they had learned something, they could share their knowledge with other people, so they could add up to an open wiki. There is an open wiki on this website, still running for 10 years, and knowledge keeps on increasing, and of course discuss on a forum. In the beginning, people were coming to the website, and you see the small link that says buy on the upper left corner. That was the only hint you could find to where to buy boards, and people were asking, where can I get these boards? Come on, there is a buy link on the website. And we learned that you have to make it really big and orange in the middle of the page so people know. You want to buy here, get boards. So if you want boards, you know where to get them. At the end of this talk, I want to see like 200 orders, okay? But documentation is not the only thing. It's also very, very important to have a working software. And what we did in Arduino was to get a working software for beginners. And here's when your eyes bleed, sorry. So this is me programming 15 minutes ago the most basic example on the Arduino IDE, which is to make a light blink. It's highly pixelated, and the light is a bit burned. Arduino has about 20-something basic commands that is a C-based language. So when you're typing code in the Arduino IDE, you're typing C. So C syntax applies. You can import C libraries. As long as they fit in the memory of the board, it's no problem. In the 32 kilobytes board, you can load, you know, big chunks of the string, libraries, and things like this. So you can do a lot of parsing and so on. Since you can't really read this, I will show you the program at higher resolution. So this is the basic, the hello world of digital electronics. The Arduino board, like many other embedded computers, doesn't have a screen, doesn't have a keyboard. So when you write code for it, you cross-compile it in a computer, and then you send it to the other place. One of the key aspects behind the Arduino success, many people don't think about it, is that it cross-compiled over any operating system. It cross-compiled on Windows, which is 70% of the Arduino user base, but it cross-compiled on Apple, and it cross-compiled on Linux. And the interesting thing is that our early adopters were Apple users. And I'm pretty sure that your early adopters are also Apple users, if you think about it, because it's you and your friends, right? In our case, we're design students and art students that are mostly Apple users. So if you give a really engaged user a tool that really works for him or for her, they will do whatever they can to talk to their friends about how cool this is. If you take design students, which business is tell people how good their shit is, because they are design students, they're going to talk about it a lot. This translated that in 10 years, we spent €0 in marketing. Because design users were making fantastic YouTube videos and the best, like the nicest pictures with the right angle and the right lighting of their boards. So we didn't have to spend anything in photography or anything, which was great for an organic growth of a platform that came so early on that there was no competition. We really had zero competition in 5 years, which also means we could make no money in 5 years because nobody really understood what we were doing. You know, in the first 5 years, I think we made around $100,000. And we took those $100,000, and instead of like doing something like nice for ourselves, I could have a car now, for example, which I don't. I have 3 bicycles. What we did was to invite the most prominent members of our community to come together in a trip to New York for 3 days and sit with us and discuss what in hell are we supposed to do now. It's like, okay, guys, we made it this far. We have like 500,000 boards out there. What can we do now? People said, make a company. We went on, and we didn't want to make a normal company because we were 5 people in 5 different countries. So we went into making a multinational. So Arduino right now is a multinational with 6 offices in 6 different countries. So I run the Swedish office. And what happens is that since we're so distributed, we get audience from all over the world. Arduino is one of the most global education companies you can find because we also have a distribution model that is very similar to the software model. You know, as long as you can sell 1 board to somebody, you can be a distributor. So you can call us and say, I want to buy 50 boards. 50 boards is a really small amount. And then you can just buy it and resell it, and you're a distributor, and you enter the deal. And you can continue being part of it. So we have distributors in absolutely every country in the world. Okay, maybe not the Antarctica, but there is Arduino players in the Antarctica. So besides, the Antarctica is a continent, not a country, so who cares? So what has happened is that since we started, a whole ecosystem of boards has shown up. There is hundreds and hundreds of different boards by different manufacturers that aim at doing very similar things. And in these slides, you will see just, I think it's like 70 boards. This is less than 1/3 of my personal collection of circuit boards. I don't know how many I have. My girlfriend says I have a really serious syndrome that I have to fix. I have boxes and boxes and boxes. And at the office, they don't like them anymore. But some of them are historical prototypes, like this one. That red one was a historical prototype of the Arduino Mega, for example. So I have to keep them until a museum calls and asks me to donate them, you know. And some of them, like this one, was made by Google. Like big companies, they go into like, oh, we want to make an open source system for people to prototype physical devices that connect to Android. What can we do? Oh, these Arduino people, they make this open source thing. Let's make it. Also, let's not tell them, so we put them in danger because then they need to support something that they haven't designed. What about that? So if you guys work for Google next time, give us a call. I mean, we appreciate the effort, but you know. But I want to tell you a couple of different stories about what people have been doing with Arduino. And all my talks, I brag about how much I hate robots, and I personally hate robots. Like, I don't hate robots like I don't believe we can make machines that can fulfill the laws of Asimov, right? It's not like that. It's like I think in education there is a lot more you can do than robots, especially with digital electronics. You can do wearable computing, you can do 3D printing machines, you can do, you know, assistive technologies, not necessarily robots, but people feel very attracted to robots. So I have a bunch of stories that have to do with robots. This is the first Arduino project that came from somebody we didn't know. In 2005, we get this email. You know, 2005 is when we started the project. And the only thing we had was a really crappy wiki. It was made, it's PM Wiki, that we had running on our website until recently. And a picture of a hand holding a circuit board like this, saying, this is open source, take it, and don't call us. You know, we don't want to know. And this guy from China sends an email like, oh, I really would like to do something with this board of yours, because my teacher is forcing me to use this 8081 thing. And we're like, sure, but the board costs 15 euros in parts. Send it to China costs 20 euros in parts with a post. What if you just go make it yourself? And the guy answers, I don't know how to make it myself. So I took the circuit board that was double-sided. I redesigned it to be single-sided. I make a step-by-step manual, like take this thing, buy this acid, etch it this way, and so on. 1 day later, he sends me a picture of his working board. And then I understood, like, okay, people are actually ready, to take control of this thing and make their own thing. It's like when in software you give people the right instructions to install your package, they will install it and use it, and they might eventually give something back, right? So what happened in this case is that I was so excited about it that I took the parts, I put them in an envelope, asked him for his address, and I sent him the official board from those first 300. And I let Malmö University pay for the mail, because 20 euros for an envelope, I'm sorry, but, So Malmö Högskola, or Malmö University, paid for the thing, I put it in the thing, and 15 days later, we get this picture. And this robot that you see here, I always believed this guy had made it, but later on I understood he hadn't made it. This is from a Japanese brand called Gakken. If you are really interested in very nice magazines, just Google Gakken. And they make these collector's magazines in Japanese only. I don't speak Japanese, but they are pretty as hell. And in one of them, they give you this robot. It's a multi-bit robot. So you can mount it. The guy was mounting the robot, and he used Arduino to hack the robot and give it intelligence. And he was controlling it wirelessly from his compact iPad. It's like, I was in a shock. At that point, I didn't even know that there were like Bluetooth chipsets that you could buy, And so this was the first story. In 2006, we got a high school teacher that had so little money that he was recycling everything he could to make his robots. So you see the cork here from a bottle, these cheap toy motors that he would buy for 3 euros. This is from a roll-on from a deodorant. This was a really good-smelling robot. Still unclear to me if it was male or female, but it was good-smelling. But in this way, with a very small investment of about like 20 euros per student, he could actually have a whole class with robots. Because that's one of the biggest issues for me, is that if you want technology to be an educational tool, you need to have as many as possible in the class. The sentence of one man, one vote. I'm the kind of person that says one man, one card. But of course, you also need to have one man, one computer, and the whole thing. I continue with Mexican robots now. So I think the guy from Minecraft was talking yesterday about how his personal life has influenced his professional life. Actually, like I guess everybody else here, when in 2008 I got a kid that completely transformed my life. So I'm a man on a mission to change education. But at the same time, I got this grant to work at an art center in Mexico City. I have been looking forward for this grant for like 2 years. And the plan was that I was going to go there and revamp a computer room for kids in the poorest neighborhood in Mexico City. And so I was puzzled. What shall I do now? I cannot disappear for 4 months. And so I discussed with the Spanish Agency for International Cooperation that was giving me the grant about what can I do with this. And I told them, what if, instead of going there for 4 months, I go there for 3 years, but what I do is that I go 2 weeks every 2 months. So I can take off time of my normal work. I can use the money you give me only in flying tickets. I basically earn no money in the project. But in that way, I can spend the 4 months full-time there over 3 years, and I can really work with the kids. So I'm sorry, this is really small and my head is really big, and especially my ears. Look at this. That was to relax the tension because the story is getting really And then, so I spent there, literally I spent 3 years going to Mexico every 2 months, working with a group of 90 kids. I don't remember any of their names, because the group of kids was changing all the time. The neighborhood has 3 million inhabitants. This is the neighborhood. So the flow of kids is changing. From one day to the next, half the kids will be different. So at some point, after 2 years, I asked the kids, okay, what next? I taught you everything I know, which is not really true, but we had been making music instruments, we had been sending data to a computer, doing a lot of stuff. I said, what can we do next? And the kids told me, robots. And I was like, what? I said, robots. And I said, well, I really think there is other things we can do, but since I already did everything that I have, I've been teaching electronics for 13 years now. So I have a repertoire of things. I don't need to prepare a class when I go into a class. You know, depending on the students, I improvise the class. Depending if they are following, then I just change on the flow. And if they want to do IoT, I do IoT. If they want to do music, I do music. I don't care. For me, it's about the experience. And these kids wanted to make robots. So I was like, okay, what are we supposed to do now? So the problem is the price. The problem is that robots cost money. And I was in Mexico, and I had like no money in the grant, so what shall I do? So I repurposed the Arduino IDE. I created a library to control a robot, and I repurposed the Arduino board, and I remade it into something that we could do there. We could etch the circuits. We could, I found motors from a toy store. I found somebody making wheels in Mexico City. I found somebody selling the microcontrollers. So I made a robot 100% made in Mexico. And I gave it to the kids. And we made 15 or 20 of these, and we started making experiments. And you know, after all this effort, the kids, this is what they did. This is the so-called Comfy, the egg that smokes dope. It's a comic, it's a cartoon character. And its eyes blink. There you go. It looks better on GIF, actually. The one thing of this art center where I managed to establish the computer room is that they are making gigantic papier-mâché sculptures. So the kids, they had other activities of the days in the week where they were making paper-mâché sculptures. So they made like 15 different shells for this thing. What happened also is that my partner Massimo is teaching at different universities just like me, and one of his students at some point, a couple of years ago, came to the idea of teaching kids robotics when they are really, really young. They don't know how to read or write. They don't know how to use a computer. And he thought it would be very interesting to teach them about how to write programs with small wooden blocks. So funny enough, I was just done with this other project. I had documented it well enough, and he asked me if I could give him one of the circuit boards for him to make his prototypes. His prototype became a product that you can now buy if you want to. I got it from Kickstarter, and it's the Primo robot. And I'm really proud to say, like, I'm really happy to see that, you know, something like this that is open source can be reused by somebody else to make another open source product that can inspire kids to do other things like this. So what you see there
is composed of 3 separate elements.
Well, I will talk for the voice because otherwise, basically you have a robot, you have a programming interface, and you have the blocks that say you go straight, stop, turn to the right, turn to the left, you know, and jump to the function. And one of the most interesting parts of this programming language is the go to the function thing. So the kids can design a function with 4 commands, and they can tell the system, jump to the function and repeat it now. It's really, really beautiful. And this whole thing was prototyped on this other system. And it's a do-it-yourself kit. So when you get it, you get the whole thing in wood and parts, and you mount it yourself, and then you get to play with it. It's super, super nice. If you're interested, it's called Primo, P-R-I-M-O. So just get one for your kids. Actually, the robot project was in 2010, and this project I just showed you went on Kickstarter like 2 years ago. What happened in between is that I was contacted by 2 teenagers from Spain, and at the time they were like 14 and 15. 15 was a girl, Nerea, and 14 the guy, Ivan, and they told me, David, you don't know this. We are from Spain, from Madrid. We are 3 times world champions in robotic soccer. And I saw where this thing was going, like, oh no. And we like Arduino a lot because we jumped from being the last ones in the table to be the first ones in the table 3 years in a row because we're using Arduino. And we want to make the Arduino robot. And I was like, fuck, no. Because when somebody calls you with an offer like that, you have to say yes, you know. So it's like you can't really run away. So we spent 2 years. Just imagine these kids, they are experts. They spend 3,000 euros in parts, in the most expensive motors, and they build distributed intelligence, and they spend 1 year, 3 hours a day, every day in the week, building a robot, and they go to a competition. And when they go to these competitions in the RoboCup, they need to explain everybody else in the audience how they made their robot. Because they're not allowed to compete if there is a minimum sign that what they did is not made by them, that it was made by the coach or somebody else. So it's a completely open source competition. Before you play, you actually say what you did. And you give everybody an opportunity to crack you down, you know, the night before. And we spent 2 years building this, which is the Arduino robot. And it's a video I'd really like to show because it also shows my kitchen. So now you see how I live. They have an automatic rainbow in the back, 24 hours rainbow. But this video shows a very important aspects of the Arduino philosophy that I didn't mention earlier, and it is that between the moment you take a circuit board and the moment you start programming it, there should be a time span of maximum 5 minutes. You know, and you should get really quick success. So when building a robot, it's very different than when you just program an LED to blink. You know, you need to have a platform that by default is very easy to make move backwards, forwards, turn left, turn right, and so on. So this is the Arduino robot that we built and even had its own screen to give you information about the experiments you were building. And yeah, here you can see how it works, and we're programming it on the kitchen table, and it's nice. And we're going to discontinue it because it's too expensive. Because one of the key aspects of technology in education is that it has to have a reasonable price. And this robot, with all the effort and all the work, ended up costing 200 euros. So we designed the next thing where we, after trying a lot of things with kids, realized that the things that kids were interested in the most was in behaviors, was in, you know, making your own robot dog or making your own robot insect that was grabbing stuff and so on. So we scrapped the previous project, kept the basics, and started to work in making something that would fulfill the user needs. This time, a normal user, not world champions, but normal user. So we made this robot that can become a dog or can become an insect where all the mechanical parts are made of cardboard. And in that way, you can fold it, paint it, redo it multiple times, and if you break it, you can just redo it very quickly, and it's no problem. There you go, pick it up, carry it away. Nice. But again, you make your robot and the kids do whatever they feel from it, you know. You make it look very nice, and it becomes Garfield with 4 eyes. So, yeah. Well, I was actually, we made this robot for a summer camp we make in Spain. And this is, every year we run a summer camp in my hometown in Zaragoza, where 600 kids come over a period of 5 weeks, 120 kids every week, and they try different things. So last year we made 150 of these robots only for them, and we give them away. And, well, I want to show you some other projects. So this is another robot. This is a Spanish performer, and they dance for kids. And I think there's a part of the performance I'm not completely agreeing with, but it's kid-friendly somehow. By the same way you can make robots, you can also hack cars. And this is one of the funniest projects we have made in Arduino, I would say, where we were asked to hack a car in just 9 days and make it drive by music. So here the guys play music and the car drives by itself. And I can't really show you the full video because this was never released. The company thought I was looking too dangerous. I wonder why. But it was really, really funny to build. It was very stressful because we were playing against the clock, and it was very funny. Also, I don't know if this year is the 30th anniversary of Super Mario. So this is one of the projects made by some of my students at the university, which is the Mario flower, you see? And you have to catch the thing before it bites you. This is, I don't know if you ever heard of Scratch, the programming environment made by MIT for kids. App Inventor, for example, is based on Scratch. These kids, they are 15 years old. They made their own CNC machine controlled from Scratch and hacking a CD player. As the summer camp I was talking about, we realized that when you finish a summer camp, you always need like a big event for kids. So we made this Arduino controlled Coke Mentos fountain. There's an Arduino that's pulling the string that pulls out or pushes the Mentos into every bottle. And if you have never seen this thing, it really works. It's fantastic, you know. There was a moment of tension there. I think the motor got stuck, but then it continued. This with sound is like crazy. It's like, ah, kids screaming, going crazy. This is another project made by 15-year-old kids in Castilla in Spain. You know, 4 kids in a class, they built a full R2D2 of recycled paper and motors. This was made by a single kid who wanted to have a machine for people that can't speak sign language, to talk sign language to people that can only read sign language. So he made the phone to control the robot hand, and he built the whole robot hand. And here you will see how he's testing robot hand. There you go. Again, this is a 50-year-old kid, okay? Just, I think, has quite some credit. You can also make your own machines. This Arduino-made Segway. And you will see now there's a lot of things hanging from the roof. You see, those are scarves made by a circular knitting machine. This is made by 2 artists, Mar and Barbara. I commissioned this machine. It's a completely open source knitting machine, so if you need to make socks, yeah, you can make your own machine 3D printed and go crazy making your own socks. I'm going to skip this one. So you can Google Star Watch. With the Arduino IDE, we hacked the Sony smartwatch, and you could completely reprogram it. So it's possible to... The idea behind the whole Arduino system is that you can hack the hardware, you can hack the software, and you can repurpose other systems that use some sort of microcontroller that could be compatible to be reprogrammed from the same IDE. So it's been ported to a lot of things. And as a proof of concept, actually Sony paid us to port the Sony Smartwatch 1 into the Arduino IDE. It took us 48 hours, and it was very interesting. And then this guy made a whole computer game to run on the smartwatch. And I want to close with this installation because it has a really nice story behind it. This is a light installation that was commissioned by Nike, and we made it in the city of Jakarta. So this was for you, Firman, since you were around. So this is Century Park, and Jakarta is a very polluted city. It's very big, and we were asked to make a light installation for the last 100 meters of a 10 kilometers run that Nike was arranging. So we decided to get 15,200 LEDs and make them into a nice light installation. And as you were running underneath the installation, the light was going to be following you and making nice light patterns. We had planned to mount this thing in 4 days, but nobody told us it was monsoon period, so it was raining all the time. It took us 16 days, day and night. We had to work when it was not raining, obviously. The good news is that you can totally sink an Arduino board into water and it keeps on working, okay? If you dry it afterwards. But the most amazing thing is that Nike forgot to tell us that the marathon was going to be running during daytime. So nobody could see the light installation. So you're quite fortunate because you can see it on video. So, guys, this is everything I had to say. There is hundreds of stories that I could tell being done with Arduino. I just want to thank my team in Malmo. This is just half the team. So you know that we are a lot of people behind this. Thank you very much.